Welcome, my dear learners, for this course on engineering graphics. So far, we have discussed about the projection of prisms. So from today's class, we will be heading our discussion towards the projection of pyramids. So before moving to solve problems on pyramids, in this class, I will be introducing the prerequisites to approach the problem on pyramids. Let us discuss the nomenclature of pyramids first. In case of prisms, we have seen that both the base as well as apex seems to be the square, pentagon or hexagon depending on the prism which we are discussing. Whereas in case of pyramids, only the base will be square or pentagon or hexagon depending on the pyramid which we are discussing. Here the apex will be a point to which all the longer edges will be connected. In case of pyramids, we term the longer edges as slant edges. So moving on to the nomenclature, only the base will be specified. Let us say I have a square based pyramid. In case of pyramids, all the edges that are the longer edges moving from the corners of the base will join at a common point which is termed as apex or the top of the axis, and these edges are termed as slant edges, whereas for the base the edges are termed as base edges, and we have base corners. And one more important thing is that the triangular faces, slant triangular faces. Therefore, if you clearly observe, a square based pyramid will have 4 slant edges and 4 slant triangular faces. Similarly, if I draw a pentagonal pyramid, the pentagonal pyramid will have 5 slant edges and 5 slant triangular faces. Similarly, for hexagonal pyramid, we will be getting 6 slant edges and 6 slant triangular faces. Since the faces are slant in nature, this makes the top view different for the pyramid compared to the prisms. So therefore, if I look at this pyramid from top, I can see slant triangular faces in their apparent dimensions. Therefore, whenever we are marking the top view of a pyramid, from the center we should join all the base corners with a dark line with the same thickness as the base edge thickness. This indicates the slant triangular faces. Slant triangular face number 1, slant triangular face number 2, slant triangular face number 3 and slant triangular face number 4 with their apparent dimensions. Whereas in case of prisms, we are not joining the corners to the center in its top view when the prism is standing on HP, whereas for a pyramid, when it is standing on HP, in the top view you should join with a thick line from the center to the corners so that you will get the triangular faces in the top view also. Next, moving on to detect the invisible edges for pyramids. The important points to be remembered are: first, identify the farthest base corner, very important, base corner to the observer. Once you identify the farthest base corner to the observer, all the edges will be invisible except at boundary of the pyramid. What does except at the boundary of the pyramid means? So if I get the top view of a square pyramid whose axis is inclined to horizontal plane to certain amount of angle, then according to us, in the top view, all the edges moving from the farthest base corner should be invisible except at the boundary of the pyramid. Here the boundary refers to the lines which I have drawn with the help of blue chalk. The lines which have the blue color are making the boundary of the pyramid. Except these, whatever the edges coming inside will be invisible if they are emerging or moving from the farthest base corner to the observer. And the second important point is that common lines cannot cross over. If there are any two slant edges crossing over like this, then one must be invisible and one must be visible. Whether these edges are slant edges or base edges. Two visible edges can never cross over, or two invisible edges can never cross over. This is the second important condition to be known to find the invisible edges. So by knowing these two important points, we can detect the invisible edges while solving the problem on pyramids. With these basic knowledge, let us move on and solve our first problem on pyramids. The problem number 7 states that a square pyramid of 35 mm side of base and 60 mm axis length rests on HP on one of its corners of the base, such that the base edges containing the corner on which it rests make equal inclination with HP. Draw the projection of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and VP at 30 degree. If you observe the problem, he has given the inclination of the axis twice, first time with respect to HP, again with respect to VP. Therefore, in the final view, we will be getting the apparent axis. Hence, we should find the apparent inclination for this problem, which is nothing but the beta angle for this problem. The square pyramid is resting on HP with one of its base corners. Therefore, in the first position, I should make the pyramid stand on HP without inclining to any of the planes, such that in the top view I should get the corner towards my right hand side. Since it is a square, I will get corners on the either side. So in the second position, since it is resting on HP in the first position, I should show the inclination with respect to HP itself. Whereas in the third position, I should show the inclination with respect to the remaining plane, that is with respect to the vertical plane. Therefore, in the first position, pyramid stands on HP. In the second position, I should show the inclination with respect to HP itself. That is, axis inclined to HP at an angle of 40 degree. In the third position, I should show the inclination of the axis with respect to VP at an angle of 30 degree. Here he has given the true inclination. Let us draw the XY line. For us, this is vertical plane and this is horizontal plane. Now, if I look the square based prism standing on horizontal plane in its top view, I can see the slant triangular faces with their apparent dimensions and also the corners of the base. Therefore, draw a square such that you will get corners towards right side. Since it is a square, obviously you will get one more corner towards left side also. Instead of using protractor and compass to draw the square resting with one of its corners, let us use the set square of 45 degree angle. So this angle is also 45 degree, here also I have 45 degree. With the help of 45 degree set square, I can draw the square resting with its corner very easily compared to the conventional method where we were using the protractor and compass. So let me demonstrate that. First, you mark horizontal on one of the corner of this diagonal. Draw 35 mm line inclined at an angle of 45 degree on either side. So if I keep the set square of 45 degree angle in this manner, so I will get 45 degree on either side. So therefore, draw 35 mm once you draw 35 mm inclined angle of 45 degree on either side, now draw parallel lines on the remaining corners. So this completes a square with corners on either side such that when I project I will get the diagonal. Since this is a pyramid, to the center draw dark lines from all the corners. Now if I view the pyramid in the top view, I can see the top of this axis whereas the bottom of the axis is invisible. Therefore, O is visible, O1 is invisible. Coming for the corners, all the corners are visible to us. Therefore, we have A, B, C and D. Now, take the projection vertically upwards and mark the axis first. The axis length is 60 mm. Therefore, draw an 60 mm length which gives us the axis of this pyramid. Once you draw the axis, connect the apex to the corners. Now, if I see in my front view, the slant edge BO1 will come in front of OO1. Therefore, I cannot see the axis. And also, axis is always invisible in front view. We cannot mark the axis for this diagram because the slant edge BO is coming in front of the axis. So therefore, I cannot show the axis also. Now, join the base. In the front view, observer will be here. To the observer, the corners A, B and C are visible corners, whereas the corners D, O and O1 are invisible corners. Therefore, A prime, B prime and C prime are visible corners, whereas D prime and O1 prime are invisible corners. At the top we have O prime. Axis is always invisible in the front view. Now show the dimension of the axis as well as the base edge. Now to incline the axis at an angle of 40 degree to horizontal plane, if you clearly observe, the base is perpendicular to to the axis. Therefore, if I incline the axis, the base and the axis will construct an triangle. If I clearly observe, I am getting the axis inclined to HP and the base A prime, C prime passing perpendicularly and resting on HP. So you get C prime. This angle is already known. This is 90 degree. This is axis and this is base. Now this angle is also known to us. Is given in the question. This angle must be equal to 40 degree. So therefore, what angle must be made by the base in the clockwise direction to get the axis inclined angle of 40 degree can be easily determined. It is nothing but 180 degree minus 90 degree minus 40 degree, which gives us 50 degree. So therefore, if I rotate the base at an angle of 50 degree and construct the pyramid once again, automatically the axis will make at an angle of 40 degree to horizontal plane. So employing this clear-cut concept, I can redraw the pyramid such a way that the axis of the pyramid will be inclined at an angle of 40 degree to horizontal plane. So first mark 50 degree clockwise and draw the base A prime, C prime. Measure the base and transfer. I have transformed C prime and A prime. I also mark D prime, which is invisible, B prime, which is visible, and O1 prime, which is invisible. Now mark the axis. Axis length is already known, which is 60 mm. Draw a perpendicular line to this base measuring 60 mm. From the apex, join to the remaining corners. I got O prime. Now, if I extend the axis and measure the angle, definitely the angle will be 40 degree. Now, draw the projection vertically downwards and also from horizontal and mark all the base corners and the apex. Mark all the corners of the base. I have A. In the top view, the observer will be here. The farthest base corner to the observer is C prime. So therefore, all the edges emerging from C prime are invisible except they lie on the boundary of the pyramid. The edges emerging from C prime are B to C, C to D, and the slant edge C to O. So now if I mark these invisible edges, none of the edge will come on the boundary of the pyramid. So therefore, marking the invisible edges, I will get D to C is invisible and C to B is also invisible. Base edge AB is visible and AD is also visible. Now, joining the slant edges, A to O will overlap on the invisible edge CO. Therefore, give preference for visible edge, join AO. And finally you join B to O and D to O. This completes the top view in the second position. Now I should copy this diagram, paste here and rotate such that the true axis is inclined at an angle of 30 degree to VP. But if I measure the axis length is less than 60 mm. Therefore, for true axis length of 60 mm, the angle of inclination is 30 degree. For this apparent length, how much is the axis of? Mark O as reference. Measuring the true axis length, transfer the true axis. So now fix the locus. Now measuring the apparent axis length, intersect this new locus, which will give us O1. Now join O1 and extend it to intersect the XY line. Now measure the inclination, which will give us the beta angle for this problem. Beta angle turning out to be 43 degrees. Using point O1, draw a perpendicular by making O1 as center and find the corners D and B. Extend the axis line. Using compass, measure D to A and D to C. From point D, cut the reference. Which will give us point A and C. Now join the corresponding corners using invisible and visible edges. Now draw the slant edges. This completes the transfer of the diagram, in which the axis OO1 is making an angle of beta, which is 43 degree with vertical plane. Now take the projection vertically upwards and horizontal. Now mark all the corners. Now in the front view, the observer will be here. So to the observer, the farthest base corner is D. So all the edges emerging from D are invisible except they lie on the boundary of the pyramid. The edges emerging from D are D to C, D to A and D to O. If I mark them, I'll get D to O, since D to A and D to C are coming on the boundary of the pyramid, it is always visible. And also if you see, for the observer, the base is visible. Therefore, since D to C is coming on the boundary, mark it as visible. Also, D to A is also coming on the boundary, mark it as visible. And finally we have D to B and B to C again. Now join the slant edges. I'll get A to O, B to O and C to O. Finally mark the axis O prime to O1 prime. The boundary for the pyramid is O prime, A prime, D prime, C prime and O prime. Therefore, any invisible lines coming on O prime, A prime, B prime, C prime and O prime are marked as visible edges. Using our second condition, common lines cannot cross over. You can observe here, one is invisible and another one is visible. So this completes our problem number 7, in which we have solved our first problem on projection of pyramids. And if you clearly observe, I have used same color for these two front views and same color for these two top views, which means that these two are similar in dimensions and these two are same in dimensions. As per the given question, the square based pyramid is resting on one of its base corner on HP. The corner is C prime, which can be seen here also. That's all from this lecture. Thank you.